Okay, so this is chapter 5 course division for chemistry. It's halogens, that's later. I'm looking at grade 10 material right now, but it's because it's the same as 11. But we have for chapter 5, we have these questions. Okay, I'm also going to solve 19 and 20 because they're grids and they're highlighted, so I think we should do them. So I'm going to go through these very quickly because they're very easy. Okay, when 4 moles of Fe reacts with excess chlorine, what mass of FeCl3 will be produced? Okay, to do this, you need to write the equation. You have Fe reacts with chlorine gas to produce FeCl3. So always write whenever it's like this. And these questions, they never come in the exam like this. But if you ever get something like this, where it's ambiguous, you have to write the equation. Some people might ask why I put Cl2. It's because chlorine gas is always Cl2. Okay, gas. Okay, obviously you need to balance this, so put a 3 here and a 2 here. Okay, and now since you have 2 irons here, you need to put a 2 here. Okay, you have 4 moles of Fe, so we're going to use RR and GR. Those of you who are familiar with my channel, you use RR and GR for all of these exercises. So 2 here, and how much do we have given? 4. Okay, what are we talking about? What are we looking at? The mass of FeCl3. Okay, how do you find the mass of FeCl3? In RR, how much do you have? How much is FeCl3? You just find the molar mass of it. Fe is 56, Cl is 35.5. So you guys, I'm pretty sure you're all familiar with how to find the molar mass of anything. Fe 56 plus 3 times Cl, so times 35.5. You get this, 162.5. But remember here, in our reaction, we have 2 FeCl3. So what do? Multiply by 2. Okay, so it's 325 over here. And in your GR, we don't know how much, so we put x grams. So you cross multiply, and let's do it. 325 times 4 divided by 2. And you get 650. And remember, the unit is grams. 650 grams. Okay. Question 3. Okay, now we want question 3. And they're pretty much the highlighted questions in the document. Hydrogen gas reacts with carbon monoxide to produce methanol as shown in the reaction. When 0.5 tons of hydrogen reacts completely with carbon monoxide, the amount of methanol was 3 tons. Calculate the percentage yield. Okay, percentage yield has a formula. Percentage yield, okay? It's equal to the experimental yield over the theoretical yield times 100, and a percent, of course, right? What is experimental yield? The experimental yield is always what's given in the question. So here they said the methanol produced was 3 tons. So this is the experimental yield, how much they got in their experiment. Theoretical yield is what you find yourself. You need to go do that yourself. And how do you find theoretical yield? You find that by doing RR and GR and cross multiply. So this is our reaction. We're just going to take it down here. Okay. And we're trying to find the theoretical yield. How do you do it? Simply cross multiply. So RR and GR. What do we have given? We have 0.5 tons of hydrogen gas. Okay, so ignore the unit tons. We can just solve as if there's no unit. Okay, some people, they see tons, they get confused, oh, how do I convert to grams, whatever. No need. Okay, because we're talking about percentages, because tons will cancel out later on if you're working with percentages. As long as they're all the same unit, tons, then it's fine. Okay, so 0.5 tons of hydrogen gas. In the RR, I have 2 H2. H2, I'm sure all of you know, H2 is 2. The mass of H2 is 2. So 2 times H2 is 2 times 1. Because the mass of each hydrogen is 1, so 2 hydrogen, whatever. Okay, so RR is going to be 4. Right? GR, how much given do I have? 0.5. طيب. What are we looking at? We're looking at the yield. Yield is how much you get at the end. Okay, so CH3OH. So I want to find the mass of CH3OH. How much is CH3OH? You can do it. Just find the mass of it. C is 12. You have 4 hydrogen, huh? Be careful. So plus 4 plus oxygen, which is 16. This is going to be 32. Okay, so here's going to be 32. And here we're going to put X. Cross multiply. Let's see how much the theoretical yield is. So 0.5 times 32 divided by 4. You get 4. So X is 4. So the theoretical yield is 4. But how much do we have? 3. So to find the percentage yield, it's equal to the experimental yield, which they got 3, over the theoretical yield you have times 100%. Okay, so it's going to be 75% 75%. Okay, this is how you solve any yield question. Okay, over here, question 3, 75%. Type, what's next? They want question 17, 20. Okay. Okay, the metal zinc reacts with acid to release hydrogen gas, H2. What volume of hydrogen gas will be produced at room temperature and pressure? So they want RTP. Okay, RTP, this is important, but sometimes they give it to you. When 3.27 grams of zinc react completely with excess sulfuric acid. Okay, and they gave it to you. The VM, it's 24 decimeter cube because we're at RTP. Sometimes in the exam, they didn't give this in the CA. Okay, they didn't give this. They expected you to know that RTP is 24 and that STP is 22.4. Okay, for those of you who don't know, RTP is 24 dm cube, and STP it's 22.4 dm cube. Okay, you should know this. Anyway, we want to find what's the volume of hydrogen gas. Again, here you need to know the reaction. If it's not written for you, you need to know how to write it. So zinc reacts with an acid to release hydrogen gas. Okay, they didn't mention the acid, so actually in this question you can just put Zn plus acid to produce, and by the way, metal plus acid gets you salt plus hydrogen gas. Okay, you can put this in the written, but if you want, you don't have to write all this. You can just write, because this is what's important, is zinc H2. Okay, and you guys know from the previous chapter of salt preparation, metal plus acid gets you salt plus hydrogen gas, and this is how it is. This is balanced. The metal should be alone, and H2 will be like this. There should be no coefficient here, there should be no coefficient here. This is from salt preparation. You know, in case, you know, you'd be like, oh, طب why didn't you balance? It's a known reaction, metal plus acid. Okay, anyway, you can just write this, zinc to produce H2. They gave us 3.27 grams of zinc. We want to know what's the volume of hydrogen. Let's do again, RR and GR. What do I have given? 3.2, or let's start with RR. We're talking about the mass of zinc. How much is zinc? Zinc is equal to 65. If we're going to put 65. How much is given? 3.27. Type. For hydrogen gas, and what am I talking about? And I'm talking about the volume. So let's see. We have, how much is the RR volume of it? We're talking about RTP, right? Remember, to find volume, you just multiply the amount of moles, or the coefficient, or the moles, or whatever, by whatever value you have, by Vm. In this case, since we're talking about RTP, Vm is 24. Many of you, you know it fast. Oh, خلاص, I have 1 mole, so it's just 1 times 24. Okay? They don't think about it. So it's 1 times 24 because it's 1 mole of hydrogen. Type. What's my GR? I don't know. We're trying to find it. So x dm cube. What do? We cross multiply. So 24 times 3.27 divided by 65. You get 1.207. It should be, let's see how many significant figures. 3 significant figures. So let's see. So it should be 1.21 dm cube. So x is equal to 1.21 dm cube. Let's check the answer. Maybe I'm wrong. It's question 17. 1.2. They put it to 2 significant figures. I think because the mass of zinc is 2 significant figures. I didn't see that. Yeah. So 2 significant figures is just going to be 1.2 dm cube. I didn't see the zinc. Okay. You always take to the least amount of significant figures. Type. 17 is done. They want 21, 22. I can go straight to 21, 22, but these two are grid questions. You can skip them if you want, but I'm just going to solve because they're grids and they always come in. Okay, the empirical formula of a compound is CH2O. If the molar mass is 60, what's its molecular formula? Okay, whenever you see a question like this, here's what you do. The empirical formula, the molecular formula is always the empirical formula multiplied by a coefficient n. Okay, this coefficient n, it's very easy to find. N is equal to the molar mass of the original one, or the initial molar mass, over the molar mass of the empirical formula. Very easy to find. The molar mass of the initial one is 60, so it's 60 divided by the molar mass of the empirical formula, CH2O. 12 plus 2 is 14, plus oxygen was 16, 30. 60 divided by 30 is 2. So n is 2. So what's going to be the formula? You now take this 2 and we distribute it in. So it's going to be C2H4O2. Very easy. Let's see, is this correct? C2H4O2. Okay. Question 20. A hydrocarbon is 75% by mass carbon. Find its empirical formula. Okay, this question, I'm going to take it to open board just so, because I've never solved a question like this on my channel before, and I want you to be familiar in case it comes in written. A hydrocarbon is 75% by mass carbon. Hydrocarbon means CXHY. It's any formula with carbon and hydrogen. Okay? طيب. Anytime you've given the percentage of the masses inside the formula, or maybe you've given the mass, not even the percentage, they just give you the mass, you need to follow these steps, okay? You're going to start by listing your elements, and we're going to write a table, okay? The first thing you do is, if it's 75 carbon, so you're going to assume that it's out of 100. So 75 out of 100, so you're going to write the percentage. So carbon is 75, hydrogen is obviously going to be how much? 25. This is your first step. Right. The second step is to divide by the molar mass and find how many moles. Okay, carbon is 12, right? So how do you find the moles? It's just m over m. So you need to find the moles for each one. So I'm going to put n. Okay, that's the second step. Okay, 75 divided by 12. And how much do you get? Let's see. 75 divided by 12. 6.25. How about 25? Hydrogen, its molar mass is 1, so you do 25 divided by 1 equals 25. Okay, now you're going to do another step. You're going to do the moles divided by the least moles. Okay, so you're going to take this number, okay, you have now 6.25 and 25. You're now going to divide them by the smallest number between them. So what's smaller, 6.25 or 25? 6.25. So that means since 6.25 is the smaller number between them, you can divide both of these by 6.25. So you're going to do 6.25 divided by 6.25 and you get 1. And then now you're going to do 25 divided by 6.25. Let's do 25 divided by 6.25. You get 4. That means now you're done. The formula is going to be CH4. Let's check this. CH4. Okay. Very, very important to know how to do this. Okay. Especially for IGs, if you're going to do IG. You need to know these steps. First step, you assume, you write down the masses, okay, or the percentages. You then divide by the molar mass to calculate how many moles of both. Then you divide both of those moles by the least number of moles between them, okay. Very easy, and then you get the subscript for each. Now 21, 22. Okay. 21, during a lab session, students were asked to prepare hydrated magnesium sulfate by adding an excess of dilute sulfuric acid to magnesium oxide. Each student was handed a different mass of magnesium oxide. This is the reaction. So this is very easy over here. Basically, it's 5 students, student A, B, C, D, E. They used different masses of oxide and they got different masses of crystals produced. They're asking us to find which one has the highest percentage yield. Some people are going to be confused here because they can't use the mass, like our percentage yield formula is the experimental mass produced over the theoretical yield, right? But here we don't have any theoretical yield, you're not going to go cross multiply and do this, do that. So to save you time, this will always work. It won't give you the exact number of the yield, but it will see which one's higher, which one's smaller, okay? If you have a higher yield, the ratio of product over reactant will be higher, okay? So let's see. Over here, 9.5 over 5, we're going to divide product divided by reactant. 9.5 divided by 5. It's 1.9. So I'm just going to write them all here. 1.9. Then 24 divided by 10 is obviously 2.4. You don't need a calculator for that. 35.8 divided by 16 should be 1.9 as well. Or no, sorry. Yeah. 2.2375. 2.2. Let's just put it as 2.24. Okay. 46.6 divided by 24. 1.94. And then 56.7 divided by 36, 1.58. So which one here has the highest ratio? It's what? Student B. Okay, so let's check the answer. B. Yes, to find the answer, find the ratio of mass over product, mass of product over the mass of oxide, which in this case is the reactant, and choose the option with the largest ratio. Very, very easy. Question 22. I just want to go over 24 is definitely not required. Yeah. 25 as well is definitely not required. 23, don't. I don't think this is required. Yeah, 23 is required. It's 22. And I just want to give a nice note that for our final, the top questions came copy-paste. So make sure you know the top questions. Also, at the end of the chapter 5 notes, over here, chapter 5 here, at the end of them, there's a problem solving session. Okay, make sure you go over it. But for grade 10, I'm not sure if you haven't had chapter 4 in your written before, then make sure you also do the problem solving session at the end of chapter 4. At the end of chapter 4 and 5 notes, you have this. These come in the written a lot. Okay, so if you have extra time, solve them. Maybe 1 or 2 questions. Get used to it. Okay, question 22. Ammonium sulfate is used as a fertilizer. It's produced from ammonia in the chemical equation, whatever. Calculate the maximum mass of ammonium sulfate produced from 680 grams of ammonia using the following steps. Okay, calculate the moles of NH3 in 680 grams. So they're doing it step by step. How do you find moles? It's M over M. So 680 divided by the molar mass of NH3, which is 17. Let's see. 680 divided by 17. You get 40, so it should be 40 mole. Please don't forget your unit, okay? Deduce the number of moles of NH4 to SO4. How are you going to find the moles of NH4 to ammonium sulfate? You're going to do cross multiplication, because we have now the moles of ammonia and the RR, we have the moles of ammonia and the GR, and they want us to find the moles of ammonium sulfate. How do you do this? Very easy. RR and GR, right? So we have, let's put the 40 over here. And let's continue our solve. I'm going to take the reaction down here to NH3. I'm going to ignore this because I don't need it. NH4 to SO4. RR and GR. What do we have in the reaction for NH3? 2 moles. How much do we have in our given? 40. NH4 to SO4. We have 1 mole in the reaction. How much given? We don't know. X. Cross multiply. You're going to get X is equal to 20 mole. Calculate the mass, the maximum mass. This MR means like the mass of, produced, okay, of NH4 to SO4. Sorry, MR, means molar mass. Not maximum mass. MR is molar mass. Let me take the calculator up. How do you find the molar mass of NH4 to SO4? Very, very easy. When you have a compound like this, some people forget about the 2 over here. Okay? Don't. NH4, we're first going to find NH4, then multiply by the 2. NH4 is 14 plus 4, 18, times 2, plus now the SO4. S is 32, oxygen is 16, so 16 times 4. And you get 132. And please don't forget the unit. This is a mistake, by the way. They should have put, this is written wrong. It should be NH4 to SO4. It's the unit of it is 132 gram per mole. Okay, that's the unit. Calculate the maximum mass of ammonium sulfate produced. You now have how many moles? You know the moles. You know the molar mass. How do you find the mass? Mass is equal to the moles times the molar mass, right? Using the formula, N is equal to M over M. Just cross multiply. N times M. So we have 20 moles, 132 grams per mole as the molar mass. So 132 times 20 gets me 2640 grams. So M is equal to 2640 grams. Again, Usually, we could have done all of this in just one step, right? But they want us to follow these steps. Let's make sure 2640 grams. Oh, and they wanted me to put 20.0 here. Let's see. Why do they want 20.0? So I think because they wanted 40.0 here, because it's 680 grams, which is 3 SF. No, that doesn't make sense. No, I don't agree with that, صراحة. Why? Yeah, you have 2 over here. No, these significant figures are wrong. Unless they won't count it. They won't count it. It's fine. So this is correct. We're done for chapter 5. Thank you so much for watching, and good luck in your exam.